Oh, hello, this is Ainimba Chilean. Hope you're all doing well. So, this simple lecture, we shall be talking about concurrency in Java. We will task to explain some concepts in Java. So, I was tasked to explain about concurrency in Java. So, what is concurrency in Java? Concurrency in Java, this is the ability to run multiple tasks or multiple activities within a single program. How important is concurrency? Concurrency helps us to share resources, that is like the CPU, the memory, and this helps us to save resources. So, concurrency means executing multiple tasks during the same period. In Java, concurrency allows different parts of a program to run independently, making the application faster and more responsive. So concurrency is like running multiple tasks during the same period. So it allows different parts of a program to run independently, making the application faster and more responsive. Why is concurrency important? Concurrency improves performance by allowing better CPU utilization. Instead of waiting for one task to finish, if one activity has been scheduled, in case of waiting for it to first finish, then you begin or you start another activity, which is tiresome or which wastes time. Here, concurrency hopes like to run multiple tasks using the CPU. Multiple tasks can run together using threads. In Java, concurrency is mainly achieved using threads. A thread is a small unit of execution within a program. So how can I explain a thread? I can use an example of our search engine, e.g. the web browser. For example, we always open different tabs. You find you have one tab open, you have almost 5 tabs open, and all of them are all open in our webs or in our search engine, which is the Chrome. So all those different tabs that are been open, you can call them threads that are running in one application, which is the search engine, which is our Chrome. So how do we create threads? We create threads using 2 methods. We have the extended class and we have the implement the runnable interface. Extending the thread class majorly means inheritance. Inheritance, we already looked at it in our basics of OPP. Inheritance is that the child class takes over the characteristics of the parent class. For example, if you're a father and you have a child who has the same eyes or ears, you can say your child inherited your ears from you. So that is one of the methods of extending threads. And the second one is implementing the runnable interface. Extending the thread class doesn't allow us to create multiple threads because it doesn't allow multiple inheritance. But implementing a runnable interface, which is the better method, allows us to create many threads as we wish. So I'm going to explain this using an example. For example, here I have a simple program that implements a runnable interface. Here my simple program prints numbers. My simple program prints numbers for I is less or equal to 3, then I plus plus plus. So here, that is my simple program. Int is equal to 1, I is less or equal to 3, then you I plus plus, then you print the I. So here, how am I going to implement my runnable interface? Of course, here, that is calling the method, the runnable interface equal to the new runnable thread A. Oh, and so here, our first one, already I have there, the thread T1 is equal to new thread, then that is the task Then I already have thread 2 is equal to new thread. So here in my output, you can see already I have 3 threads. I have A, B, and C. So you can see here in my output, I have with thread C, which is equal to 1 thread is 2, and already another 6. That's C, 1, 2, and 3. It means it is printing 1 up to 3. And also another thread, which is A, does the same, prints the numbers that are less or equal to 3. So I can create many threads as I want. I can, maybe, for example, I'm using a thread A, but I can even say up to thread B. So I'm creating many runnable interfaces doing the same thing. So for example, let me comment out this, maybe. So here, you're going to rerun our program and see what it prints. I've commented out the 2 lines, that is the thread T3 and the thread T2. And I've also commented out the method that is allowing us to start the second thread. The start calls the run and it runs another thread. So maybe I'm going to run this Java thread. My program is called thread.java. Here I'm compiling. My laptop is a bit slower. So be patient with me. So here we have the different threads, that is thread C, thread A, thread B. So it means in the runnable interface implementing, you can create as many threads you want. That is how more of advantage it is compared to the other method of implementing. You're also going to try out the other method of implementing a thread or inheritance. We see how different it is from this method. So this is the Java. So you see here, it's only here my output is that only 1 thread had to run. And once 1 thread runs, it means that is not concurrency. So that's why I have multiple threads, 1, 2, 3, up to this. So that is runnable interface. In case here we can create another thread, maybe we can call another thread for to see that you can create as many threads as you want. Let me create another thread. Mhm. We can call this thread maybe Y. You can carry it for because it's being going to be a new thread. Then you can call it and call it Y. And then, of course, having created the new thread, we have to start it. That is to call the other method that helps it run. That is that form dot start that helps it to create to run it. So here I'm going to compile my simple program. So after this, we are going to also look at the other method, which is implementing the child class or implementing the inheritance, which allows us to run a thread. It's still compiling, so here we are. So you see here, it has brought my new thread that I created. Remember, I was creating the thread one. So with the runnable interface, you can create as many threads I want. So that's why we encourage to use implementing the runnable interface. So here is my output. We have Y, we have B, we have A, we have C. So it means all the threads are in case I can create all threads up to infinity. So we are going to look at the other method, which is inheritance. For it, it's different because it doesn't allow us to create multiple threads. You see, I created thread A, B, C, Y. I would create as many as possible, but the difference here with the thread class is that it's different. It doesn't allow us to create many. Developing a program, you can see how you can create multiple threads or multiple tasks to run within your program. So here,